Well, I'd like to thank the organizers for inviting me to this meeting. I've been to this meeting before, but it's been at least 10 years, so it's great to be back. And I didn't make a disclosure slide, but I'm wearing the disclosure. I'm co-director of the Food Allergy Research and Resource Program, and we have about 90 member companies, so I'm conflicted probably more than anyone in this room, but I have a balance of conflicts because of the number of companies that we've assisted over the years. And I have a very complex topic this morning to talk about allergen thresholds. And so I'm going to go through a lot of slides kind of quickly because Brent gave me the title of New Knowledge, and it is a rapidly emerging area. So clinical oral challenges have clearly demonstrated that each person with food allergies has a personal individual threshold dose below which they will not experience an adverse reaction. So a guy by the name of Paracelsus said back in the 16th century, I think, that the dose makes the poison, and that's true for allergens as well. And I put in all caps, we have human data. So often, as toxicologists and risk assessors, we have data on mice and rats, and we're trying to interpolate it to humans. Here we actually have human data from the sensitive segment of the human population. And a distribution of individual threshold doses can be used to estimate population thresholds, which could be used to establish the percentage of allergic consumers who would be predicted to react to any specific dose of an allergenic food. And today, that science is pretty solid, and that's what I'm going to try and tell you. Dr. Stallings mentioned that one of the key things in the National Academy's study was to dispel misconceptions. This is the misconception that I'd like to dispel. We know that trace amounts of offending foods can trigger allergic reactions, but it is not zero. And severe reactions do not occur at low doses. Obviously, I need to define low before you should be comfortable with that comment, but there are so many people out there, and they're located in the public health authorities, but also in the food industry, who believe that low doses will provoke severe reactions, and that's simply not true. And it's not supported by any observations. Currently, public health authorities have not established regulatory action levels or thresholds for any of the allergenic foods, and in fact, in many countries, we have a de facto zero threshold concept for labeling. But I would argue that this zero threshold approach is disadvantageous to all of the stakeholders, and let me show you why. For food allergic consumers, they have a diminished quality of life because their food choices are limited, very limited in some cases. They're faced with a proliferation of precautionary allergen labeling. I call it PAL. They live with a constant fear of experiencing a severe life-threatening reaction, even though some of them probably never would. They attempt to make personal risk decisions based on their own personal interpretation of PAL statements. And many choose to consume some PAL products. The public health authorities are disadvantaged as well, I would say, because they spend a lot of time chasing zero, and they therefore may miss some of the biggest risks that exist in the food supply. They fail to recognize that many of the actions they take have no public health benefit because they're chasing zero. And they end up with a reportable food registry where undeclared allergens are the #1 reason for recalls. But I would argue that it's probably true, hard to prove, that many of those recalls are associated with products that have questionable, if any, risks. And they foster and even encourage the use of precautionary labeling. Physicians are disadvantaged as well. They must deal with scared and frustrated patients on a daily basis. In my view, if you treat them all the same, then they're all going to believe that they are the most sensitive people in the population. And most of them just aren't. The physicians have no simple approach for identifying the most sensitive patients, or therefore a way to give them differential advice, even if they could identify them. And many advise at least some patients to ignore precautionary labeling and eat the products anyway. Well, the food industry is definitely disadvantaged by the zero threshold concept. Obviously, you can't achieve zero, and you can't prove that you did even if you managed to. You cannot trust that any detectable level of allergen by any method would not be considered a regulatory violation. And I would argue that many companies are reluctant to establish corporate threshold levels without any regulatory guidance. Who's brave enough to do that? Therefore, they make heavy use of PAL statements, which disadvantages the allergic consumers, and companies also have a limited ability to select the best analytical methods, which are key to assessing the risk in the first place. In the analytical test methods industry, I should disclose that I get royalty payments from Neogen Corporation for analytical test methods that we helped to develop at the University of Nebraska, but I'm still very critical of this industry at the moment, because with zero, the incentive exists to continue to pursue ever more sensitive methods, so therefore zero keeps getting less. We have no need to reach agreement because of the zero threshold concept on the harmonization of test methods. So there's a lack of standardization of reporting units, standards, validation criteria, and test methods, I would say, have unfortunately become a major obstacle to the adoption of thresholds, which is really unfortunate because this could have been fixed a long time ago. So what does the food allergic consumer see? They see this. Precautionary allergen labeling abounds. You can't read this, but there's hundreds of different statements. I used to collect the statements. I gave up when I passed 50. There's got to be hundreds. And may contain, made in the shared facility, made on shared equipment. Brent mentioned made in a nutty environment. There's crazy ones. Here's one. These are not hard to find. So allergy information. All ingredients are wheat-free, gluten-free, nut-free, peanut-free, and trans-fat-free. I don't know what that has to do with allergies. All mixes are packaged on equipment that processes wheat, milk, egg, soy, and sulfiting agents. May contain traces of peanuts and tree nuts. The major allergens are milk and egg, but oh, by the way, may contain soy. I don't know, you know, I have a PhD degree. I don't understand what that means. Should I eat this product? I don't think I want to eat, and I don't have allergies. So I can summarize PAL. It was originally intended to serve the allergic consumers. It doesn't. It's a mess. And that's an international statement as well as my personal view. It doesn't serve these consumers well at all. That's because it's not truly risk-based. And it's very confusing to consumers to have all of these different terms. They think there's a difference based on what you say on the package, and there isn't any. I would argue that PAL serves the food industry better than consumers because it allows them to identify potential risks without really having to assess the risk. And PAL serves the public health authorities best of all because they can avoid difficult risk management decisions. So for the FDA and other regulatory agencies around the world, these voluntary statements can be used to communicate potential risks to consumers. And they only have to adhere in the US and most other countries to the general labeling law expectation that the statements be truthful and not misleading. Unofficially, that promotes the expanded use of precautionary statements because all of those statements are probably truthful and not misleading. Our own criteria are that voluntary statements can be used to communicate potential risks to allergic consumers, but there should be some constraints. You should only use those statements judiciously in situations where the contamination is documented, sporadic, because if it's always there, that does contain, uncontrollable, and potentially hazardous. And potentially hazardous means you need to figure out what the risk is in the first place. So is there a better way forward? Well, now I'm going to go to the National Academy of Sciences because they're the latest ones to indicate that there might be a better way forward. So can we improve policies and especially prevent severe reactions? And Janan Stallings shared these slides with you, so I'm going to jump forward to the one that is key to the topic I have today. The food industry, together with the regulatory bodies, should work cooperatively to replace the current PAL system for low-level allergen contaminants with a new risk-based labeling approach, such as the VITAL approach used in Australia and New Zealand. Now, VITAL stands for Voluntary Incidental Trace Allergen Labeling. So if you go into a little bit further depth in the report, you'll see that FDA and USDA FSIS have to establish reference doses for allergenic foods where possible. And the committee believed there was sufficient clinical data on thresholds for peanut, milk, egg, certain tree nuts, soybeans, wheat, fish, and crustacean shellfish to establish reference doses. With reference doses, foods should have precautionary labels only when consumer exposure might result in doses above the reference dose level. We further recommended that FDA should restrict allowable PAL statements to one phrase. Then consumers won't be confused. There's only one phrase, and if you see it, it means you shouldn't try it. And of course, there's a big educational component here as well, and the food industry and the public health authorities should join forces in that effort. So now back to my personal opinions. So the science of thresholds. Clinical data do exist from diagnostic studies, from threshold trials, and especially now from immunotherapy trials, and those data are both published and unpublished. Our group collaborates with a group in the Netherlands called TNO. They used to be our competitors. We decided to join forces so that we had a harmonized international data set of individual threshold doses. And we use dose distribution modeling to determine the population thresholds, which can be used as the basis for reference doses. So we use published studies or unpublished clinical data. The subjects must be food allergic by history. Ideally, they have positive double-blind placebo-controlled food challenges. We will allow open challenges for infants under the age of 3. They have to have a description of the no observed adverse effect level or the lowest observed adverse effect level, because if they have that, which is more typical, and you know what the dosing regimen is, you can discern what the no well is by knowing the low well. We want data on individual patients, and we look for objective signs and symptoms as opposed to subjective. And here's the data we had for vital back in 2012 when we helped the vital group to establish reference doses. We had really good data for peanut, milk, egg, and hazelnut, adequate data for the ones in yellow, and we had data for the ones in red, but an inability to model that data using parametric statistical models. And here is that data set from 2012. We had over 1,800 data points. If you think we don't have very much data, we have a lot of data. We have 750 individuals with peanut. I can guarantee you statistically, if you give us another 500, the data's not going to change. It's going to take a lot of information to change any of these population-based thresholds. We've moved that forward to have a lot more new data, as you can see in the right-hand column. And if I'll just show you one of the dose distribution curves. So this is a log normal curve of the peanut allergic population based on the 750 peanut allergic individuals in 2012. So each one of those black dots represents one or more subjects. You can see that there's a wide range of threshold doses for the peanut allergic population. The most sensitive individuals react to tenths of a milligram of peanut, whereas other peanut allergic individuals have to eat multiple peanuts, gram levels, in order to experience allergic reactions. And clinically, those individuals have very different risks in the free living community. So we fit the threshold data to parametric models. We calculate eliciting dose values and confidence intervals. You can see the confidence intervals on that previous slide were quite tight. And for the Australians, we used either the EDO1, the dose that would be predicted to provoke a reaction in the most sensitive 1% of the population, or the 95% lower confidence interval, the EDO5, when we did not have enough data to do the EDO1 estimate, and that would be the ones in green were the ones that we had the EDO1 estimates. And of course, the accuracy of these estimates depends on the population sampled, the number of subjects, and the statistical approach. But here are the vital reference doses. This is old news, so I won't leave it up very long. These are in milligrams of protein from the allergenic source rather than milligrams of whole peanut, for example. So if you want to convert from protein to whole peanut, you multiply by 4. But we think the doses should be in protein so that you can adjust between the different kinds of foods that physicians use in challenges. For visual learners, I'll show you this slide. So the doses that you see here, the lowest dose that's provoked an objective reaction in peanut-sensitive individuals is 0.4 of a milligram of peanut protein, of peanut, which is 1/10 of a milligram of peanut protein. And we've had 4 such individuals out of 750 back in 2012. And even up to 100 milligrams of peanut, only about 30% react. Now, there is some consensus on this kind of approach. Clear back in 2006, FDA said that probabilistic dose distribution modeling was the best approach to use to establish thresholds, but they haven't done it yet. Europroval agreed with that and Vital actually used it with the Australian Allergy Bureau. ILSI Europe also endorsed the Vital reference doses in a report released in 2014, and now we have the U.S. National Academies endorsing this approach as well. So why don't we have allergen thresholds if we have this kind of consensus? Well, there's widespread concern that very low doses provoke severe reactions. That was that misconception that I highlighted early on. We have to change that or we're never going to get movement, even where we have consensus. There's a concern that whether the threshold data are representative of the entire population with allergies to the particular food. And almost all of those ones that I have on the slide, severity, age, and geographic origin, have been evaluated and don't seem to be cause differences. The form of the food does make a difference. And I don't have time to go into that this morning, but it can make a difference. And the choice of model was very concerning to risk assessors at public health authorities, because we failed to use the most conservative approach in every case, which is almost always the Weibull model. So we're now pursuing model averaging. Do the results of controlled clinical challenges parallel the reactions that occur in the community? Yeah, they sort of do. The reactions in the community, this data hasn't been released yet, but most of these people made big dumb mistakes in their avoidance diet. That's why they got sick. Could the dose escalation approach used in clinical challenges promote temporary desensitization? So the concern there was, when you do these challenges, you incrementally increase the dose till you make the patient sick and then you stop. Could immunological tolerance, oral tolerance, occur just from that process? Well, we did a one-shot study that's soon to be published, and I want to talk to you a little bit about that. And then a whole bunch of uncertainty factors that people are worried about as well. So let's look at I call this the one-shot study. The more polite name is the single-dose challenge study, where you bring in peanut allergic patients and you give them a single dose. It was used to try and validate the EDO5 dose that was used in the Vital exercise, to determine if any of the dose distribution models were more predictive than others, and to assess the safety of single-dose challenges, because if this works, it allows you to very quickly identify the most sensitive subjects in the population, which I said right now clinicians can't do, and to assess the severity of reactions at these low doses. So we had collaborators in Ireland and Australia, as well as in Boston. We recruited 375 unselected consecutive patients from the 3 centers, because that's what the statisticians told us we needed to do. Anaphylaxis was not an exclusion criteria. They needed to have had a reaction or a positive challenge in the last 2 years, or definitively high skin test or IgE results, and we stopped when we were only looking for objective symptoms, but we recorded all observations. So I don't have time to summarize the whole study for you, but out of 378 patients, only 8 reacted, which is 2.3%. So we found that the EDO5 dose from the original prediction was too conservative. Why? I think it's probably patient selection criteria. The log normal and log logistic models are the best predictors. The Weibull model is way too conservative, by a factor of at least 10. Single-dose challenges are safe, and the single-dose approach could be used to develop a clinical approach to identify the most sensitive patients within 30 minutes. and no severe reactions occurred at the EDO5 dose. So I had a lot of collaborators on this study. I want to acknowledge Jonathan Herrehane, Katie Allen, and Wayne Schreffler in particular, who led their groups. Once you have this kind of information, you can do quantitative risk assessment. So in quantitative risk assessment, you have the threshold dose distribution on the right-hand side of the graph. You have the product consumption patterns from in-Haines surveys or other approaches on the left-hand side of the graph, and you have analytical information about the concentration of the allergen in the middle. And when the dose, the predicted dose, exceeds the reference dose, then you would predict that an allergic reaction might occur. And we have all of these inputs readily available. The threshold dose distribution information, which I said is pretty solid, and especially for peanut milk, egg, and hazelnut. We have great food consumption information in the United States. There's probably people in this room that are more expert at that than me, but that's what we use in the United States. And we can have analytical estimates of allergen residue levels. Commercial ELISA methods are available for many allergenic foods, but unfortunately they're often not well validated, and they have variable calibrators which lead to questionable adjustment factors which confuse the users. So quantitative risk assessment is emerging as an approach. It's not widely adopted yet by industry. We think it should be. We do have human threshold data from allergic consumers. We have good analytical data with some caution. You got to be able to interpret what you have. We have reliable consumption information in the United States, and we can do quantitative risk assessment, and we should, and industry should really take the lead in developing a better approach to precautionary allergen labeling, but I think the best way forward would be if the public health authorities would set the level so that industry isn't faced with that, because if individual companies have to do it, it's likely to be variable. Thank you very much.